Okay, so we're looking at determining the slope-intercept equation of a line with the following features. And we have, in this problem, we have that the slope m is equal to 3, and we have for the point through which the line is going to pass is designated with the coordinates 4, -6. And now, looking for the slope-intercept equation, now we have the given slope and also a point through which the line is going to pass. So if we look at taking the route of setting up what we have in terms of the point slope form of a linear equation. So again, we have y minus y1 is equal to m times the quantity of x minus x01. And again, we have the tools available with the ordered pair x1, y1, and also the slope is given. And if we substitute, now we have for y minus y01, okay, this will become y minus, okay, and y01 we have at -6 is equal to the slope m, which is provided at 3. And we have times the quantity of x minus x01 and x04, or x01 is equal to 4. And again, just in the rewrite, the subtraction of a negative. So we have y plus 6 is equal to 3 times, okay, the quantity of x minus 4. Okay, so for what we have at this stage, this is going to be the point slope equation. And in following through, so as to isolate y, we can take care of the parentheses on the right upon distributing 3 over the binomial x minus 4. So we're going to have 3x minus 12 on the right. And looking at isolating y, so we're going to end up subtracting 6 on both sides. And so for what we will have here, it's going to be y is equal to 3x minus 12. And again, this is going to be the slope-intercept equation. And you can go back and check the results. Okay, so again, the slope was given as 3. So we have the slope-intercept equation, whatever is next to x, okay, is going to be the slope, so we have it 3. And to test out 4 and -6, so if -6 is y and x is at 4, we're going to have that the left-hand side of the equation is equal to -6. And so for what we have in this case, again, it never hurts to double check. Yeah, 3x minus 12, take away 6. Okay, so I have -12 minus 6, you have -18. I did that intentionally. I'm kidding. Okay, so we have taking away 6 from both sides, so you have y is equal to 3x minus 18. So again, double checking, so you have the left-hand side, we have at -6. Then we have 3 times 4 is 12 minus 18, also at -6. Alright, now, so we were able to develop the slope-intercept equation from a given point and slope. And once again, just sort of in the late cases of what we have, where we have looking for the slope-intercept equation where we have not the slope given along with a point, but 2 points through which the line is going to pass. And so we have, for this particular line, it's going to pass through -4, 8, as well as -7, -3. And in looking at what we have here, Okay, now we don't have the slope given, and we'll have to find out what that is. And first things first, okay, so we're going to have a set of x and y values to work with. And now, so we have a negative 4, 8. Okay, so letting this be the first set of x and y values. And negative 7, negative 3 be the second set. Again, keep in mind that all ordered pairs are of the form xy. And so for what we have in this case, if we look for the slope, okay, so again we have y of 2 minus y of 1 all over x of 2 minus x of 1 so we're going to have here, okay, so you have y of 2 minus y of 1, so we have negative 3 minus 8. And we have for x of 2 minus x of 1, so we have negative 7 minus negative 4. And for what we're going to have in the development, okay, so you have negative 3 minus 8, so that will be negative 11. At the bottom, okay, so we have negative 7 plus 4. So we're going to have negative 11 over negative 3. And here the negatives will cancel out. So the slope, okay, we're going to have a non-integer positive value with the fraction 11/3. And now, so we now have the slope, okay, and now for the points, you can choose either one to work with, okay, for taking what we have in the case of the point slope setup. Okay, so we have in this one case, so you can choose negative 4, 8. Or negative 7, negative 3. Okay, again for x1, y1 and the point slope setup. And I'll tell you what, we'll go with the second ordered pair. So we got this, and again we had the slope value is at 11/3. So we have in the point slope arrangement, okay, so you have y minus y of 1 is equal to m times the quantity of x minus x of 1. Okay. So for y minus y of 1, okay, so we're going to have y minus negative 3. And we have m, okay, so we have 11/3. And we have times the quantity of x minus negative 7. Okay. So in looking at undoing the subtraction of a negative, so again we have y plus 3 is equal to 11/3 times the quantity of x plus 7. Okay. So for what we have in the framework, okay, so we have this equation, okay, this is the point slope setup, and now for the slope intercept, okay, so if I distribute, now what's going to happen here, okay, we have 11/3 times x, so this will be 11/3 of x, and 11/3 times 7, so this will be at 77/3. And if I get the y term by itself, okay, so I have upon deducting 3 at both ends, okay, so we have y is equal to 11/3 of x. Okay, now 77/3 minus 3. Okay, let me just mention, okay, now for 77/3 minus 3, And if I were to convert 3 into a fraction, so you have like 77 over 3 minus 3 over 1. And as a fraction, okay, you have 3 over 1, and that can be written as 9/3. And so this will be at 68/3. And so we have, for the difference in this, let's say we have 11/3 of x, and we have plus 68/3. And in a sense, okay, you can go back and check. Okay, so we have, way to look at this, so you have 11/3 of x, say if x is at -4. So you have like -44/3 of x plus 68/3. -44 plus 68 is 24. 24 divided by 3 is 8. Now for x at -7, 11/3 of -7 is minus 77/3. -77/3 plus 68/3 becomes -9/3. And that comes out to -3. So both of these ordered pairs will check out for this particular slope-intercept equation. All right, and for what we have, so for both of these, okay, we have arrival to the slope-intercept equation through the route of taking the point-slope approach. But again, in number 12, okay, to be able to set up the point slope, I had to discover what the slope was given, since it was not already provided, but instead where I had to work around these 2 points through which the line passes. Now, just going back to what we have with parallel and perpendicular lines, and we have for the case in number 23, okay, now we're looking at in this one case, you have a slope m, which we have at 3/11. Okay, now, and we're looking at trying to find out, okay, the slope of the line that's going to run parallel, as well as the slope of the line that's going to run perpendicular to a line that has a slope of 3/11. Okay, so again, we have for a parallel line, again, parallel lines are going to have the same slope. So in this case, you have the slope is equal to 3/11. And for a perpendicular line, now again, the relation between the slope values of perpendicular lines will be opposite sign reciprocals. Okay, so for 3/11, you have a positive 3/11, and opposite sign, we're going from a positive to a negative. And then we have for the reciprocal of 3/11, okay, that's going to be minus 11/3. Okay, and you can always go back and check. Now again, for perpendicular lines, you know, the product of the slope values, okay, will be -1. So you have like 3/11 times -11/3, and you can cross multiply by just taking what we have here. So you have -33 over 33, and that goes to -1. So the product of the slopes of perpendicular lines, okay, will be at -1. And for what we have in the case of number 26, okay, we have the given slope at -10. Again, so for a line that runs parallel to that which has a slope of -10, again, parallel lines have identical slopes. So we have m is equal to -10, and then we have for a perpendicular line, okay, when we have that, the slope is going to be going, so we have going from a negative to a positive, and then the reciprocal of 10 is going to be 1 over 10. So again, just kind of restating. So we have for the product of slopes, so like negative 10 times 1/10. So you have negative 10/10, and that reduces to negative 1. Okay. Now, and what we have in determining whether, okay, we have the given lines are going to be parallel, perpendicular, or neither. Okay. All right, so you have posed the question. Okay, so you have whether 2x plus 3y equals 7 and 4x equal to negative 6y plus 2. Okay, are they parallel, perpendicular, or neither? Okay, so to find out the answer to that question, okay, if they're parallel, the slopes will be the same. If they're perpendicular, the slopes will have opposite sign reciprocal values. And if you don't have either of those cases, well, you're not going to have the lines to be parallel or perpendicular. So we have, looking at the determination of the slope for 2x plus 3y is equal to 7. What we can do here is convert this equation into the slope-intercept form. So getting the y term by itself, if I take 2x away from both sides, so we will have that 3y is equal to negative 2x plus 7. And we have with division by 3, so we have that the slope-intercept form of the equation representing the first line, we have y is equal to negative 2/3 of x plus 7/3. Okay, so for this first line, okay, we have that the slope is equal to negative 2/3. Now for what we have in the case of the second line, okay, now we have the y term on the right hand side of this equation. And if I go ahead and just isolate the negative 6y, by subtracting 2 on both sides, okay, so we have 4x minus 2 is equal to negative 6y, and then dividing these terms out by negative 6. Okay, so you have 4 over negative 6, okay, this will come out to negative 2/3 times x. Now I have what's going to be negative 2 over negative 6, so this is going to be a positive 1/3. Negative 6y over negative 6, this will come out to y. And just rearranging, kind of like going from b is equal to a is equal to b format. Okay, so we had that y is equal to negative 2/3 of x plus 1/3. And so we have in the slope-intercept equation, it turns out that for the line here, the slope is equal to negative 2/3. Now we have different lines. Okay, so we have For the first one, this translates out to y is equal to negative 2/3 of x plus 7/3, and the second we have y is equal to negative 2/3 of x plus 1/3. And if you notice, okay, we have with the outcome for the slopes, okay, so we're going to have the same slope. At negative 2/3, and so for what we're going to have, because the lines had the same slope, it turns out that the lines are going to run parallel to each other. So you have parallel lines in the case of number 32. Now, for what we have regarding parallel as well as perpendicular lines, okay, we have in the case of number 37, and we have for this particular layout, okay, so we're looking at determining the equation of the line. That's going to run let's see, that runs through I'll word it this way, so you have run through 2, 5. And is, okay, so we have in part A, we're going to have parallel to the line represented by 2x plus y is equal to 6. Okay, so the given line you have represented by the equation 2x plus y is equal to 6. And so we have just looking for the equation of the parallel line. First of all, we need to determine the slopes. So we have with the given line, we have 2x plus y is equal to 6. And if I rewrite what I have here in terms of the slope-intercept form, so if I take 2x away from both sides, so we have that y is equal to negative 2x plus 6. Okay, so for this line, okay, so we have that the slope m is equal to negative 2. Okay. Now, in looking at what we have for the parallel line, again, stressing in case we have the same slope. Right. So we have in this particular setup here, okay, so the slope m is equal to negative 2. And again, so we're going to have the same slope. So I have m is equal to -2. And again, the parallel line is going to run through 2, 5. And so for what we will have here, so just going through the point slope equation setup. So y minus y1 is equal to the slope m times the quantity of x minus x of 1. So we're going to have y minus 5 is equal to -2 times the quantity of x minus 2 and -2 over the quantity of x minus 2, so you have -2x plus 4. And we have, upon getting y by itself, okay, so we have adding 5. And so for the slope-intercept equation of this line, we're going to have y is equal to -2x plus 9. Okay, so that has a slope of -2. And again, you can just check for the consistency. So for the point through which it passes, so if y is at 5, left-hand side of the equation is at 5, and with x at 2, -2 times 2 is -4, -4 plus 9 is 5, and 5 is equal to 5. So that is going to check out. Now, for what we have in the next portion, now we're looking at where the line is going to run perpendicular. To 2x plus y is equal to 6. Again, just a little bit of a repeat here, since we're working with the same line to start out with. Okay, and we have with the perpendicular line. Again, with perpendicular lines, okay, just say we have OSR for opposite sine reciprocal slope. Okay. So for the perpendicular line, okay, so you have the slope. It's going to be the opposite sine reciprocal of -2, so this is going to be a positive 1/2. Again, the product of the slopes will be at -1. Okay, and again, the point through which the perpendicular line passes, same as what we have with the parallel. So you have also going through 2, 5. And again, just initiating with the use of the point slope formula. So we have with y minus y1, okay, so we have y minus 5. And we have is equal to the slope m, which we have at 1/2. And we have times the quantity of x minus 2. So we had the point slope equation here, and in crossing over to the slope intercept, I can remove the parentheses upon distributing 1/2. So in doing so, we'll have 1/2 of x minus 1. And in getting the y by itself, and we have, upon adding 5, to both ends. So I'm going to follow that y is equal to 1/2 of x plus 4. And again, you can go back and check your result. Okay, so the slope is at 1/2, and with y at 5, you want the right hand side of the equation to also be at 5. So with x at 2, half of 2 is 1, and 1 plus 4 is equal to 5. Okay, and then we have with the remaining item from the set, and we have with number 39. Okay, so we have in this case, I know it's looking for the perpendicular line. I'm kind of have it run both parallel and perpendicular. So we have just to add a little bit more. Okay, so we have okay, so I'm looking at determining the equation of the line that runs through. And we'll say we have 6, -4. Yep, so you have 6, -4. And it is, and I'm just going to say we have for part A, perpendicular to x minus 5y is equal to 1. And the reason one reason to which I could be adding, in this case, I say like have perpendicular to come before parallel. Best I remember, like some of the ALEKS exercises. Okay, now we normally say, even in the dictionary, parallel comes before perpendicular. But I know that some of the ALEKS exercises, you might have like a first problem to have looking for the parallel, then the perpendicular, and then the next problem could have the order switched around, and some fall for that trap, just saying parallel, perpendicular, and all of a sudden it's like there's that problem with the perpendicular to determine first, and then the parallel. So if we look at the perpendicular, and we have for the given line, okay, so we have x minus 5y is equal to 1, and looking at determining the slope-intercept form, and thus the slope of the given line. So if I isolate the y term, okay, so we have taking x away from both sides, so we have negative 5y is equal to negative x plus 1. And we have with division by negative 5. Okay, so we'll come out to y is equal to, now negative over negative is going to be a positive, so you have 1/5 of x minus 1/5. Okay. So for the given line here, so we have that the slope m is equal to 1/5. And for what we have in the case of the perpendicular line, you can see you have an opposite side reciprocal slope. opposite sine reciprocal of 1/5 is going to be at -5. And the point through which the line passes okay, so again we have that, so that was 6, -4. So we have, in the case of the point slope setup, so we have y minus -4 is equal to the slope m, which we have at -5, times the quantity of x minus 6. Now for the point slope equation, this is what we have here. Y plus 4 is equal to -5 times the quantity of x minus 6. And we have, with distributing, y plus 4 is equal to -5x plus 30. And taking 4 away from both sides. So we have that y is equal to -5x plus 26. So for the slope-intercept equation of this perpendicular line, again we can test out the consistency. So with x at 6 and y at -4, again y is at -4, left-hand side of the equation here is -4, and I want the same thing on the right-hand side. And we have with x at 6, so we have -5 times 6 is -30. -30 plus 26 is also -4. And just to throw in, okay, so if I had to run parallel to x minus 2y is equal to 7, so I'm just adding in this part. So just kind of repeating what I have for the given line. Again, we had the slope is going to be at 1/5. Again, we have with parallel lines. Parallel lines are going to have the same slope. So we have the slope at 1/5. And we're working with the same point, which we have at 6 and -4. Okay, so we have with y minus y01, okay, so we have y minus -4 is equal to the slope m, so we have 1/5 times the quantity of x minus 6. So again, we have y minus -4, so this will be y plus 4 is equal to 1/5 times the quantity of x minus 6. So this stage will be the point slope equation. Now for the slope intercept, if I go ahead and distribute, so we got y plus 4 is equal to 1/5 of x, and we've got 1/5 times -6, so this will be minus 6/5. Okay, so if I take 4 away from both sides. I'm just kind of moving to the side here. So I have back-to-back negative numbers. I have negative 6/5 minus 4. You just regard that as minus 4 over 1, and just writing in terms of fraction over 5. So 4 over 1, that's going to be 20 over 5. And we have negative 6 minus 20, that's going to be negative 26/5. Okay, so in this case we have y is equal to 1/5 of x minus 26/5. Okay, and again, so just sort of checking what we have here. So y is at negative 4, and then we have with x at 6. Okay, so you have 1/5 of 6, you have 6/5, and if I have 6/5 minus 26/5, I have negative 20/5, which reduces to negative 4. Okay, so we do have consistency on this one. Okay, and now just kind of a quick exercise. So we're looking at determining so you have the slope-intercept equation. Of the line, okay, that's going to run through 410. And is, first of all, okay, let's say it's going to be parallel to 2x minus y is equal to 7. And in part B, which is going to be perpendicular to the line represented by the equation 2x minus y is equal to 7. Again, both parallel and perpendicular lines will pass through the same point. Now let's see what slope-intercept equations we get for both the parallel and perpendicular lines. Okay, just looking at what we have in the mix. Okay, so we're looking at the determination of the slope-intercept equation of the lines that will run through 410, and that will be, in the first case, parallel to the line represented by 2x minus y is equal to 7, and also where we have running perpendicular in fashion to the same given line. Okay, so we have in the setup, okay, so to be able to determine the equations of the parallel and perpendicular lines, again, we first need to know just what slope values are going to be involved. Okay, so we have, again, we have for the given line, okay, so you have 2x minus y is equal to 7. And if I take what I have here and translate in terms of the slope-intercept equation, so I'm going to isolate the y term. So I'm looking at taking 2x away from both sides. So we have negative y is equal to negative 2x plus 7. And if I multiply or divide, okay, by negative 1, or just changing the signs, like making the positives into a negative and vice versa. Okay, so you're going to have that y is equal to 2x minus 7. And so for what we have from the slope-intercept, okay, it turns out that for the given line, we have that the slope m is equal to 2. Now, for the parallel line, okay, so again, parallel lines will have the same slope. So you have the slope m is equal to 2, and the point through which the line passes, again, that is going to be at 410. And looking at the point slope equation setup. So we have with y minus y01, so we'll have y minus 10 is equal to the slope m, which we have at 2. And we have times the quantity of x minus 4. So what we have here is going to be the point slope equation. Now for the slope intercept, okay, so we have y minus 10 is equal to 2x minus 8. And then getting the y term by itself, and we have, upon adding 10 to both sides, so we have that y is equal to 2x plus 2. Okay, so we have y at 10, x at 4, and 10 is equal to 2 times 4, which is 8, plus 2, which is also at 10. And in the case of the perpendicular line, okay, so in this case, right, so you have perpendicular lines will have slopes that will be opposite sign reciprocals. Now we have the given slope, or the slope of the given line, to be at 2, and for the perpendicular, now the opposite sign reciprocal of 2 is going to be a negative 1/2. And again, we have passing through the same points with 410. And so we have the point slope setup. So again, we have y minus 10. Slope m is now negative 1/2. We have times the quantity of x minus 4. So this is the point slope equation for the perpendicular. And upon arriving at the slope intercept, so if I distribute negative 1/2 over the quantity of x minus 4, we'll have negative 1/2 of x, and negative 1/2 of negative 4, that's going to be a positive 2. And adding 10 to both sides. And so it's going to follow that y is equal to negative 1/2 of x plus 12. Okay. And you can check what we have here. So we have with y at 10, okay, so we have 10 on the left, and to the right I have negative 1/2 of 4, which is negative 2, and negative 2 plus 12 comes out to 10. 10 is equal to 10. So that is going to check out. Now, there is little part about average rate of change of function. And that's just going to be like a functional notation for what we have in the case of slope. And we're going to look into that, but this part, I'm just going to sort of, at the moment, I'm going to bypass this, but something I do want to mention, and just give you sort of a mini lesson. And this is going to be for when we looked into functions. Okay, now you had some that will run continuously, in other words, non-stop from end to end, and then you have like those other functions that were kind of broken off into separate sections, and those could be samples of what will be regarded as piecewise defined functions. And just as a bit of a sample, okay, for what we have in the case of piecewise defined functions, okay, it could be something like tax brackets for the federal returns. Yeah, something like a Form 1040. This is just an example, okay, where you have like not one function to run continuously, but where you have it sort of split up into different sections, okay. And like an example of piecewise defined function, and we'll say that we have given see we have f of x is equal to two x plus 5 if x is less than negative 2. Okay, so for values of x less than negative 2, you have f of x is equal to 2x plus 5. Also, we had that f of x is equal to 3x squared if we have it that negative 2 is less than or equal to x, which in turn is less than 5. And then we could say that f of x is equal to 3x plus 4 if we have that x is greater than or equal to 5. And in determining how this would work, for the various inputs, say if I'm looking at determining f of 20, let's say we have f of negative 40, and you see we have f of 4, and so you have f of negative 2 and also f of 5. And just so say first of all, if we're looking at f of 20, okay, so you look at your input. So x is represented by 20, and in terms of which of these three functional portions we'll be working with is going to be contingent upon how 20 fits in terms of x. So 20 is not less than 2, 20 is not between negative 2 and 5, but 20 is greater than or equal to 5. It's not equal to 5, but it does ring true with the greater than portion. So in terms, so if you have the x value to fall where x is greater than or equal to 5, then you're going to apply the 3x plus 4 portion. And guess what? So we have 3 times 20 plus 4. 3 times 20 is 60. 60 plus 4 is 64. And say for f of negative 40, in terms of which of the 3 expressions to use. Negative 40, well, that's more highly negative than negative 2. So negative 40 is less than negative 2. So we're going to use the 2x plus 5 part. So we have 2 times negative 40 plus 5 so we have negative 80 plus 5, which we're going to have at negative 75. Now, in the case of the input at 4, okay, if you notice we have 4 is not less than negative 2. And if I have 4 between negative 2 and 5, in the nature of this compound inequality, that is going to be true. Now we got negative 2. Okay, we have the less than part in relation to 4. 4 in turn is less than 5. So for 4, we're going to take 3 times the square of that input. And 4 squared is 16. And 3 times 16 comes out to 48. Now, in the case of f of negative 2 and f of 5, if you notice we had those values are mentioned in the listings, okay, in terms of where they're going to apply. Okay, now we have with negative 2. Now negative 2 cannot be less than itself. So we're not going to have the first inequality to apply. So the 2x plus 5 is not even considered. And again, negative 2 cannot be less than itself, but it can be equal to itself. And negative 2 is equal to negative 2, and negative 2 in turn is less than 5. Again, so negative 2 cannot be less than itself, but it can be equal. And so we have, in following through, okay, we have, once again, 3x squared. This time we have with x at negative 2. Negative 2 squared is 4. And we come out to 3 times 4 is 12. And as for the input at 5, okay, so where we have 5, okay, so we're trying to say that 5 is less than itself. This is not true, so this compound inequality does not apply. And we have for 5 greater than or equal to 5. Now 5 cannot be greater than itself, but we have the equal sign. So the last inequality is going to apply. So again, we have 5 greater than or equal to 5 is true on the basis that 5 is equal to itself. And so we're going to have the 3x plus 4 functional part to deal with. So we have with x at 5. Okay, so we have 3 times 5 plus 4. And we have 3 times 5 is 15. And we have that 15 plus 4 is equal to 19. Okay, so we have for the various inputs. So whenever x is 20, okay, we have y is equal to 64. When x is negative 40, y is at negative 75. And we have at x equal to 40, excuse me, x equal to 4, y is equal to 48. When x is negative 2, y is equal to 12. And then for x is equal to 5, we have that y is equal to 19. All right. And again, just now there is a little part with average rate of change. But I think I'm just going to hold off on that until next week. And now just some, and we have numbers 10 through 26 even on page 225. And I had somebody ask me about the virtual office hours, okay, and I'll be available, okay, just during the office hours, through Zoom, okay. And here's my meeting ID number as well as my password, okay. And if anybody has questions, I will stick around for the next few moments. Otherwise, we'll pick up next time on Monday.